A very good evening to all of you. I am Ajit Manna, going to teach you maths in this YouTube series. Okay, so coming to exercise number 1.5, class 11th maths set. Question number 1. We are given here a universal set, set A and set B and set C. And we have to find A complement, B complement, A union B whole complement, A union C whole complement, A union B whole complement, A complement whole complement, and B minus C whole complement. So this is all the things that we had to find out. Okay, so coming to first part, we have to find A complement. A complement simply means removing all the elements of A from universal set. Okay, so we are going to remove all the elements of A that are already present in set A, and then when we remove all the elements of A from universal set, we got our A complement set. Okay, so 1 is removed, 2 is removed from U, 3 is removed from universal set, 4 is removed from universal set. So this, the elements that we left in the universal set, is actually the A complement set. A complement. Complement is represented by simply a dash over that set. Okay, erasing this part, our first question is done. Now we have to find B complement. Second part is B complement. To find B complement, what we have to do? We have to remove the B set from this universal set once again. Okay, so 2 4 6 8. 2 4 6 8. After removing 2 4 6 8 from universal set, what we left is 1 3 5 7 9. So this is the B complement set. Now we have to find out A union C whole complement. To determine the complement, first we will have to find the A union B. Okay, so for doing question part number 3rd, we have to first find A union C. Union means adding all the elements. Adding means just writing all the elements of A and C in a single set. Okay, so in set A 1 2 3 4 is present, and in set C 3 4 5 6 is present. Since 3 4 is already written, so we will just write 5 6 here and enclosing the set. But what we have to do is we have to complement this set. So for complement, we have to remove all the elements of A union C from universal set. So in universal set, we have to remove 1 2 3 4 5 6. 1 2 3 4 5 6. So what we left is the 7 8 9. So this is the set of A union C whole complement. Okay, going for part 4th. Part 4th is saying this A union B whole complement. So what we have to do, A union B, first we will have to find A union B. A union B means writing all the elements of A and B in a single set. Okay, 1 2 3 4, and we have write 2 4, so we will write 6 8 here. But we actually do not have to find A union B. What we have to find is A union B whole complement. So we are now removing 1 2 3 4 6 8 from universal set. 1 2 3 4 6 8. What we left is this element 5 7 9, and this is our answer for the fourth part, which is saying A union B whole complement. Now we will have to find A complement over complement. Okay, so A complement we already find it. So what we will do is we will again remove this element from Universal set 5, 6, 7, 8, 9. So 5, 6, 7, 8, 9 we removed. So what we got is A complement's complement is 1, 2, 3, 4. And this is actually is equals to A. Means complement over complement is actually the same set. We done fifth part. Now we will have to do sixth part. Sixth part is saying B minus C whole complement. So first we will find B difference C. So what is B difference C? B difference C is removing set C from B. Okay. So what C and B has common is 3 and 6. So 2 and 4 and 6 has removed. So what is left in the set B is B difference C. So 2 and 4. But we actually do not have to find B difference C. What we have to find is B difference C whole complement. So we will remove this B minus C set from the universal set, and then we got our B difference C set. So we will have to remove 2 and 4 from union. 2 and 4 is removed. So all the elements that are left here is the B difference C whole complement. 1, 3, 5, 6, 7, 8 and 9. So this is the answer for B difference C whole complement. Got your answer? Okay, coming to question number 2. Question number 2 is giving us A, B, C, D, E, F universal set and find the complement of the following sets. Okay, so means we have to find A complement, we have to find B complement, we have to find C complement, we have to find D complement. So for finding A complement, we have to remove set A, elements of set A from universal set. A, B, C. A, B, C is removed. The leftover element is A complement. D, E, F, G, H. Okay. Coming to question number 2, we have to remove D, E, F, G. D, E, F, G. So what we left here is A, B, C and H. For doing a third part, what we have to do is we have to remove A, C, E, G. A, C, E, G. So what we left over here is B, D, F, H. Now coming for part number 4, they are saying F, G, H, A. F, G, H, A. So what left here is B, C, D, E. So these are the 4 complements that they are asking us to find. Coming to question number 3. Question number 3, taking the set of, means we have to take universal set as the set of all natural number and write down the complement of the following set. Okay, so first they are saying writing down the complement. So x such that x is an even natural number. So if x such that x is an even natural number, then naming it A. So what is A complement? A complement is the set of all odd number. X such that x is an odd natural number. Either you can write in this way, that is set builder form, or you can write it in roster form. 1, 3, 5, 7, 9, dot, 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 dot. Okay, coming to part second, question number B, x such that x is an odd natural number. Okay, if B is a set of odd natural number, then its answer will be an even natural number, because odd and even are actually their complement. Odd natural numbers and set of odd natural number and set of even natural number are actually the complements of each other. Okay, coming for part number 3, they are saying x such that x is a positive multiple of 3. So C part, they are saying positive multiple of 3. So we can write that not a positive integer of 3, or simply we can write that 1, 2, removing lefting 3 because 3 is the multiple of 3. So 4, 5, 6 is removed, 7, 8 and dot 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 dot. These are the elements of C complement. Coming for part number D, so we have to find a D complement. So they are saying x such that x is a prime number. So you can write x such that x is not a prime number. Okay. So which are not the prime number? Prime number are not. We have to write those number which are not actually prime. 6, 8, 9, dot, 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 dot. These numbers are not prime numbers. Okay, so we actually done the 4 part here. Doing the 5th part, which is E. E is such that x is a number divisible by 3 and 5. So number divisible by 3 and 5 is actually divisible by 15. So we do not have to write 15 in our answer. So what are the numbers other than 15? You can write it easily. 15, then we have to 16, 14, then 16, then dot 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 dot, 29, then 31, then dot 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 dot, just like that. E complement. Then we have to find F complement. F is the set here. F is a perfect square. So you can write the x is that x is not a perfect square. Which is not a perfect square? 2, 3, 5, 7, 6, 7, 8, dot, 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 dot. These are the numbers which are not perfect square. Okay, I think I will have to add one page here. Okay. Now part A is saying x such that x plus 5 is equals to 8. X such that x plus 5 is equals to 8. So if we will write it as G part, what is G? First we will have to solve x plus 5 is equals to 8, then x is equals to 3. Okay, so we will have to write all the elements other than 3 in this set, because G set has only 3 inside. So 1, 2, and then 4, 5, 6, 7, dot, 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 dot. Just remove 3 from here and it will become G complement. Coming to question number 9, x such that 2x plus 5 is equals to 9. Okay, part number 9 is what saying? Part number 9 is saying x such that x 2x plus 5 is equals to 9. Okay, now we will solve this problem. That is 2x plus 5 is equals to 9. Sending 9 to that side. 9 negative 5 of is equals to 2x, then 2x is equals to 4, then x is equals to 2. So this is H set. So what is H complement is writing all the natural number other than 2, because 2 is in that set. Okay. Coming to question number 10th. Question number 10th is saying x is that x is greater than equals to 7. Okay, so I set is x is such that x is greater than equal to 7. So in this set all the elements from 7 to greater than are written. So what we will have to write here in the G complement is less than 7 actually. 1, 2, 3, 4, 5, 6. These are the numbers which are less than 7, and that will come in the complement set. Okay, now coming to our 11th part, which is saying x such that x belongs to natural number and 2x plus 1 is greater than 10. Okay. So as in 11th part, suppose J set, okay, x such that x 2x plus 1 belongs to natural number and 2x plus 1 greater than 10. So what we will have to do is 2x plus 2x is greater than 9, sending 1 to that side, and x is greater than 9.2, which is greater than 4.5 actually. So x is greater than 4.5. In this set J, x is greater than 4.5 means x is from 5 to infinity. What we have to write in the J complement? We will have to write 1, 2, 3, 4, because 4 is not in that side. So we can write here our answer. To question number 4. Question number 4 is saying you have an universal set like this, A set, B set. We will have to verify this formula. Okay. So for verifying this formula, we have to find A union B and its complement, A complement, B complement. So we will first find A complement. What is A complement? A complement means removing all the elements of A from universal set. Okay. So removing A, 2, 4, 6, 8 from union. 2, 4, 6, 8. What left is the A complement? 1, 3, 5, 7, 9. Finding now B complement. B complement is removing set B from universal set. 2, 3, 5, 7. So 2, 3, 5, 7 is removed. What is left here is 1, 4, 6, 8, 9. Now what we have to do? We have to intersect them each other. That is A in dash intersection B dash means what element they have common. So they have 1 common and they have a 9 common. So these are the two elements which come on the right hand side. We got right hand side like this. Now we will have to find left hand side. For finding left hand side, we have to find the A union B. Okay, so we are finding A union B here. A union B means writing all the elements of A and B together. So we are writing 2, 4, 6, 8 and we already write 2. So what we will write? 3, 5, 7. 3, 5, 7. Okay, now what we have to do? We have to complement this set A union B. We will complement it. A union B whole complement means removing all the elements of A union B from universal set. So 2, 4, 6, 2, 4, 6, 2, 4, 6, 8, 3, 8, 3 and 5, 7. 5, 7. These all elements are removed from that A set, universal set. What is left here is 1 and 9. So 1 and 9 will come in that set. As you can easily see from these two boxes that I just right now draw, that these two boxes have the equal and same elements. So we can say from here, hence A union B whole complement is equals to A complement intersection B complement. So we proved this. Now we will have to prove this. For proving this, we have to find A intersection A dash union B dash. So we already find A dash and B dash. So what we will do? We will do A dash union B dash. So for writing A dash union B dash, we will have to combine all the elements of A dash and B dash. Okay. So writing 1, 3, 5, 1, 3, 4, 5, 6, 7, 8, 9. So these are all the elements which are common in A dash and B dash. Now we will have to do A intersection B and then complement it. So we are writing A intersection B first. So for writing A intersection B, we will have to find common elements which they two have. Okay, so what is the common here? Common is 2. So we will write 2. And what is else common here? Nothing else common here. So just 2 is the only element that came under A intersection B. Now we will have to find A intersection B whole complement. Whole complement means removing all the elements of A intersection B, removing this from universal set. Is its complement. So removing 2, after removing 2, these all elements are in the its complement set. 1, 3, 4, 5, 6, 7, 8 and 9. From again we can see that this set is equals to this set. So we can write here as hence A intersection A dash union B dash is equals to A intersection B whole dash. Coming to question number 5, draw appropriate Venn diagram for each of the following cases. Okay, so for drawing a Venn diagram, all we have to do is we have to just draw a rectangle which is showing universal set, and we will have we will do two sets, set A and set B. So firstly they are saying A union B. So what came under this set? A union B. A union under A union B. A union B is what? A union B is this set. Means A plus B. So this is the A union B set. Okay, but they are not saying that you just need to find A union B. They are saying you have to find A union B whole complement. So for complement set, you remove this set from universal, and this will be your A union B whole complement. This and this set, all the outer area from here is the A union B whole complement. Okay, so I am writing it here as this is the A union B whole complement, and this inside set is A union B. Our first part, this first question is done. They are saying A dash intersection B dash. Okay, so for doing this second part, we will stepwise solve our question. Okay, by doing appropriate color coding, means if you just want to find A dash set, so what is A dash set? A dash set is actually all the elements outside of A. Okay, this is actually A dash, means all the elements outside of A is A dash. All the elements outside from A is A dash. Removing all the elements of A from universal set is the A dash set. Okay, got my point? Now you will have to find out the B dash set. So this blue line is saying A dash set, and now we will have to find this B dash set. So B dash set is removing all the elements from B. Means you do not have to write any B set here. In the earlier case, you have to do not write A set, and in the second case, you do not have to write B. So this is B dash. Now what you have to find is the intersection of these two sets. Intersection means the common, the area that is common in these two sets. So what is common in these two sets? The common is obviously the outside region of these all two. So this is the common region here, outside of A as well as outside of B. This is the A dash intersection B dash. I hope you guys are getting my point. So I will just right now write your A dash intersection B dash. In the third part, we will have to do is, in the third part, we have to find A intersection B and then whole complement. So for finding that, first we will find A intersection B and then we will complement it. Okay, so these are two sets, A and B, two sets A and B, two sets A and B. Okay, so these are two sets A and B, and what we have to find is we have to find the intersection of two sets. So what is here intersection? As from the diagram you guys can easily see that this is the A intersection B part, this is the A intersection B part, this is the A intersection B part, which is common to A and common to B. So this is our A intersection B part, but they are not asking us to find just the intersection, they are saying just complement it. Complement means all the region inside universal set, removing this just a little thing, removing this common point is will be our answer. So we will just left this intersection part and highlight all the area around it, and this will become our complement of A intersection B. All the yellow region is, which I'm just right now highlighting, is actually your answer of A intersection B complement. Getting my point, guys? Getting my point, guys? Getting my point? So that's how the things are so easy when you just try and solving it using Venn diagram. So this is our A intersection B whole complement. Coming for part 4. Part 4 is saying A intersection union B intersection. Okay. So A intersection and B intersection. So what we will do in the fourth part is we will draw a rectangular box which usually drawn by two sets, and so this is the fourth question, universal set, set A and set B. First part, firstly we will have to find A complement. So what is A complement? All the elements outside the A will be the A complement. All the elements outside the set A will be our A complement, and secondary we already write A complement. Now we will have to find B complement. So what is B complement? Here is B complement means writing all the elements of except that B set, except that B set we will have to highlight all the areas that are there in the universal set except that B set. Now what does union means? Union means adding all the region. Union means adding all the region. Adding all the region means what? Adding all the regions means just A dash or B dash, anything. So this is our anything. In this region, A dash and B dash both are present. In this region, only A dash is present. Only B dash is present. In this region, only A dash is present. So these are all the regions which unite A dash and B dash. But the intersection part, that intersection part have neither A dash nor B dash. So only that region will be left in our question, and that's how we get our answer of our fourth part, that this shaded region is A dash union B dash. Now I will highlight our answer as shaded region in yellow color is the answer of all parts. Keep in mind. Coming to question number 6, let U be the set of all triangles in a plane. U be the set of all triangles in a plane, and A be the set of all triangles with at least one angle different from 60. placed one angle different from 60 degrees. So in the set A, no element have 60-degree angle. At least one angle is different from 60 means this has, if this has 60, this has 70, then this has 50. So this kind of triangles are in the A set, and we will have to remove this set. If we, so what we have to do, we will just write it. There is only one triangle left around this. After removing this 60 degree, we will have only one left. If we just write 60, it will automatically 60 here. Okay, so A dash will be the set of all triangles having 60-degree angle. All triangles having angle all angles 60 degree, and that is the equilateral triangle. Only equilateral triangle. Okay, so this is the answer of our sixth question. Coming to question number 7th here. Question number 7th is saying us that fill in the blanks and for each of the fill in the blanks to make each of the following statements true. So they are saying A union A complement. Suppose this is set A, suppose this is universal set. So they are saying A and A complement will actually the universal set. Okay, phi dash intersection A. So phi means nothing and phi dash means this whole set A. Phi is nothing, phi dash is this whole union set, and they are doing an intersection with A, then they have actually got the A. Okay, so A dash intersection A, actually A dash and A have actually no elements common, so we will get phi here. U dash intersection A. What is U dash? Tell me. U dash, U is everything and U dash is nothing. So U dash is what? U dash is phi, and phi intersection A is actually phi. You get nothing. I mean empty set. Empty set is a set of your answer, and that's the end of our lecture. Thanks for watching this wonderful lecture lesson, and see you in the next video. See you in the next lecture. That's all for today. Bye, good night.